Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Free radical benzylic halogenation under photochemical HV conditions. Moving on to the next step. Under HV, light, CbRCl3 undergoes homolytic cleavage of the CbR bond, the weakest bond in CbRCl3, since CbR bond dissociation energy is lower than CCl. This generates a Br radical and CCl3 radical. Moving on to the next step. The Br radical abstracts a benzylic hydrogen from toluene, pH CH3, to form the resonance-stabilized benzylic radical, pH CH2, and HBr benzylic hydrogens are preferentially abstracted because the resulting benzylic radical is highly stabilized by resonance with the aromatic ring. And for the final step, the benzylic radical, pH CH2, then reacts with another molecule of CbRCl3, abstracting the Br atom. Again, the CbR bond is weaker and more easily broken than CCl, to give pH CH2Br and regenerate CCl3, which propagates the chain. The net result is that only the benzylic CH is replaced by Br, giving benzyl bromide, pH CH2Br. No ring substitution occurs as stated. Why other options fail? A. pH CH2Cl, chlorine abstraction from CbRCl3 would require breaking a stronger CCl bond. Br is selectively transferred because CbR bond in CbRCl3 is weaker. C. pH CH2CCl3. This would require radical coupling of pH CH2 with CCl3, which is a termination step and not the major propagation product. D. pH CH2 CbRCl2. This would require addition of a CbRCl2 fragment, which is not the mechanism here. Therefore, the correct answer is B. Therefore, the correct answer is option B.